So welcome to my YouTube channel. Today we will start with that type of equations which are not exact differential equation. Now we will start with that equations which are not exact. Then how can you make that equation is exact differential equation, and how can you find solution of that type of differential equation? First of all, if we are saying that you have an equation of the type mdx plus ndy. Now we'll write it down. We have mdx plus ndy equals to 0. In this case, if your del m by del y is not equal to del n by del x, then you say that given differential equation is not exact differential equation. So after that, what you will do? Here we will find integrating factors. Now there are different methods to find integrating factor which depend upon which type of differential equation is given to us. According to that, we will find integrating factor. After finding this integrating factor, we will multiply equation with integrating factor. This equation, we will multiply this by integrating factor. After multiplying it, now whatever the resultant equation, that equation is now exact differential equation. Now we will use our previous method to solve exact differential equation. What is the solution of exact differential equation? That is mdx, where y is a constant, terms not containing x in n dy equals to 0. So by this method we will find a solution of the differential equation. Now here comes the question how we can find an integrating factor and which types of integrating factor would be. So we will start with the first method. Suppose that your equation mdx plus ndy is equals to 0, where your m and n are homogeneous in x and y. When your m and n are homogeneous in x and y. What does it mean? It means that whenever your m and n is a homogeneous function of same degree of x and y. In this case, our integrating factor would be 1 by mx plus ny, where mx plus ny is not equal to 0. Now, this is your rule, or you can say that type 1. This is your rule 1. Whenever your equation is homogeneous in x and y, in that case your integration factor would be 1 by mx plus ny. Now to simplify or to understand this, we will go with one equation so that we can easily understand how it is applicable. So within this we have equation solve x square y dx minus x cube y cube dy is equals to 0. Suppose that this type of differential equation is given to us. First of all, what is our first thing? That we will check that whether this equation is exact or not. Now, if your equation is exact, then the solution is directly given by this. Like, this is your solution. Now, if it is not exact, in that case, we have to find its integrating factor and we have to solve the equation. Now we will check that. We will compare this with m dx plus n dy equals to 0. Here m would be x square y and n would be minus x cube plus y. How can we check for its exact? That del m by del y. It means del by del y x square y. Now, if we are finding partial derivative with respect to y, it means that your x square is treated as a constant. If x square is treated as a constant, it comes outside. The partial derivative is only over y. So, where we will get here x square. Similarly, if we find del n by del x, similarly del by del x minus x cube plus y cube. Negative is outside, del by del x, x cube plus y cube. Again, it goes over del by del x cube plus del by del x y cube. Now, again we are finding partial derivative with respect to x. It means that y is treated as a constant. It means here if you will find derivative with respect to x and here is a y, it will give you 0. What is the derivative of this? This derivative is 3x square. So it means that we are getting minus 3x square. The value of del m by del y, it would be x square. The value of del n by del x, it would be minus 3x square. Now we can see that our del m by del y is not equal to del n by del x. Now if in the case our del m by del y is not equal to del n by del x, it simply means that this differential equation is not exact. This is not exact. Now, if it is not exact, what we have to do? We are finding integrating factor. We are finding here integrating factor. So that by finding this integrating factor, it is easy to make the equation exact and we can find a solution. Now we have done our previous method. Like if it is a homogeneous, then integration factor would be this. Now see here, in this case we have here power is 2, here is 1. So total power is here 3. Similarly, in this case, the power is 3, resultant is also 3. So it means that this is a homogeneous in x and y. It means it has the same degree in x and y. So in this case, we can use this method to find integrating factor. Now see what is the value of m. Our m could be x square y and our n is x cube plus y cube. Now its integrating factor would be mx plus ny. It means 1 over x square y into x plus minus x cube y cube multiply with y. So here x cube y minus, it will give you x cube y, again It is a y raised to power 4. Now this would be cancelled out. You will left only with 1 y minus y4. So now this is our integrating factor. This is our integrating factor. Now what we have to do? We will multiply this integrating factor with our equation. Our equation would be x square y dx minus x cube plus y cube dy equal to 0. It is multiplied with minus 1 raised to power y raised to power 4. Then we will see x square y over y raised to power 4 dx minus x cube plus y cube divided by y raised to power 4. This negative and this negative will be give you a positive dy. Now this is the value of our m and n. M and n. If we want to further simplify, we will get x cube y raised to power 4 plus xy cube y raised to power 4. This is the value of your m and this is the value of n. Now these are automatically exact. If you want to check, we can also check, but it is automatically exact if we are multiplying this by an integrating factor. Now we have to find a solution. As we know what is the solution, it would be m dx plus terms not containing x in n into dy. In this case, y is treated as a constant. So what is the value of our now m? It would be a minus x square y raised to power 4 dx plus, now they are saying term not containing x. In this case, we have a term. There are two terms, this one and this one. This term contain x, but this would be a y cube over y raised to power 4. That would be not contain x. So we will replace this by, that is a y cube by y4 dy equals to c. Now we have to just find integration for further simplification. In this case, here it would be cancel out minus x square y cube dx plus, where y is treated as a constant, plus it would be cancel out 1 by y dy equals to c. Y is a constant, comes outside, integration over x square dx plus 1 by y dy equals to c. Now what is the integration of this? It is x cube by 3 plus log of mod of y equals to c. So here we will get minus x cube 3y cube plus log of mod of y equal to c. So this is our solution of differential equation. So if I want to summarize it, what we will see? Firstly, we will check equation is exact or not. If not exact, find integrating factor. After finding integrating factor, multiply this with equation. Then again the resultant equation would be a exact. Then we will apply our method, simple direct method, to find the solution of that exact equation. So thank you very much.